students, and welcome to today Friday Happy Hour. Today's topics are going to be systems and linear equations. This topic is for 1324, but I believe also 1314 is going to see it probably within the next 2 weeks. Okay, so these are the topics that I'm going to cover for today. These come from the book Math 1324. And I believe they're section 6.1 and 6.2. Okay, we're going to cover systems of two linear equations and two variables, which consist of determine whether an ordered pair is a solution of the systems of equations. We're going to be using three types of finding solutions, which are graphing, the graphing method, the substitution method, the elimination method, and how these methods apply to real-life situations. And also, we're going to cover larger systems of linear equations. And again, we're going to use the elimination method and then also matrix and how it applies to real life situation with three variables. So to start off, let's start off by finding solutions of a system of linear equations. So this is question number 1. It says determine whether the given order list of numbers is a solution of the systems of equations. So what do we do here, guys? For example, here number 1 on the left side, it states that if is negative 1, 3 a solution to the systems of both systems here. This is equation 1 and equation 2. So the objective here, we're going to plug in negative 1 for x and 3 for y. Okay. So we know that x is negative 1, so I'm going to plug negative 1 for the x. And I'm going to plug in 3 for the y. Then all you do is simplify, so this will give us negative 2 plus 3 on the left side, which is equal to 1. So 1 equals 1. But for this to be a solution, it has to be true for both equations. Okay, I plug it in equation number 1, and now I have to repeat it to equation number 2. If this first step, if this wasn't true, then we stop there, and then we can just say it's not a solution. Okay, but we have to continue because it made it true for equation number 1. Now we're going to repeat the process for equation number 2. I'm going to plug in negative 1 for x and 3 for y. So negative 3 times negative 1 is going to give us 3, and 2 times 3 is 6. So 3 plus 6 equals 9. So 9 equals 9. So this means that since the order pair negative 1, 3 makes both equations true, then the order pair is a solution for the systems of equations. Okay, so this is a solution. So now let's do number 2. Number 2, we're going to repeat the process, but now we have different systems of equations and we have a different point. So we're going to plug in 2 for x and negative 0.5 for y. Right, so we call it equation 1, equation 2. So in equation 1, right, we repeat the process as number 1. But we're going to plug in 2 for x and negative 0.5 for the y value. After we evaluate it, it's going to give us negative 3 equals negative 3. So this is true, right? So then we continue to equation number 2. And again, we repeat the same process. We're going to plug in 2 for x and negative 0.5 for the y. After we evaluate it, it's going to give us negative 0.5 equals to negative 5, which is not true. Which means, since the order pair 2, negative 5 does not make both equations true, then the order pair is not a solution. So to wrap it up, for this for the first slide, equation 1, number 1 is a solution, and number 2 is not a solution. Okay. Okay, now students, if you have any questions as I'm covering this PowerPoint, please raise your hand up, and Patricia or Alan, they're going to stop me because since I'm showing my screen, I don't see who has any questions. Okay, I cannot see that because I'm showing my screen. So Patricia and Alan will be more than willing to stop me, and that way I can clarify any concerns or issues that you have or answer any questions. So please don't hesitate to ask questions as I'm going over the PowerPoint. Okay, now we're gonna solve by graphing. Okay, so this is a graphing method. For example, here on the left side, right, you have 2x plus 3y equals 12. So here we're gonna have, right, two equations: 2x plus 3y equals 12 and 3x minus 4y equals 1. So if you graph it, you see here's where they intersect at this point here. If they have an intersection, it means there's only one solution, right? So the solution will be 3, 2. You see graphing lines in, this is from, this you should remember from sections 2.1. Okay, but anyway, now let's go to B. If you notice, there's only one line. So what's up with that? It means that these lines are the same line, right? It's a line on top of a line, which means it's going to be infinite solutions. Infinite many solutions. And then on C here, on the far right, you see these two lines do not intersect. We have negative 6x plus 4y equals 7 and 3x minus 2y equals 4, which means the lines are parallel. They never intersect. So for C, there's no solution. Okay, now let's see how they're going to look like. Okay, for example, say that you're solving by substitution or by the elimination method. If once you get like x equals to a or y equals to b, which means if x equals to a number, that means it's going to be one solution. Okay, and here the legal math notation, it says let a and b be real numbers, which means a and b can be any numbers. Examples, x equals 2, right, or y equals 3, right? So this is a solution, x equals 3 or y equals 2. Now, if you get something like a equals a, right, when you don't have no x or y's, for example, 3 equals 3 or 0 equals 0, right? Here we don't have no x's or y's. That means if they're both equal on the left and the right, it's going to be infinite solutions. And I'll show you an example. Well, I'm doing an example of each one of these. And here on the far right, on C, so you have a equals b, right? A and b be real numbers. For example, 3 equals 4. You see no solution because 3 does not equal 4. And again, there's not going to be no x or y's. So for infinite solutions and no solutions, you don't have no x or y's. They were eliminated. But you have two numbers, right? One on each side of the equal sign. If they're both the same, it's going to be infinite solutions. And if the numbers are different on both sides, is no solution. Okay, so but I will show you an example of each one as we go along. Okay, this is called consistent independent system. If there's infinite solutions, it's also consistent, but it's dependent. And on C, it's going to be inconsistent system. Okay, when there's no solution, that's another name for these type of systems. Okay, now let's start by doing number 3 by graphing. How do we graph these? Graphing, you should be aware how to graph by now because I believe you covered it in chapter 2. Okay, but anyway, let's do a quick review on graphing. If you have equation number 1, right, equals y equals to 3x minus 6. So we know that my slope is equal to 3, right, because this is in the form of the slope-intercept form. So my 3 is my slope, right? But you always put it as a fraction. Why? Because it's going to be the rise over the run, which means 3 is equal to 3 over 1, right? And the b is a negative 6 is always the y-intercept. So we know that from here, right, we're going to start at 0, negative 6, because that's my b, which is down here at the bottom, 0, negative 6. And then this is a rise over the run. The rise means that it goes up and down, and the run means goes across, horizontally. So since they're both positive, I'm going to start here at negative 6 at my starting point. I'm going to go up 3, 1, 2, 3, and 1 to the right. You see, guys, if I keep going 1, 2, 3, 1 to the right, it's going to be the same, the same line. But anyway, we only need 2 points to graph a line, so we graph it. You see, and if you notice, if I go up 1, 2, 3, 1 across, 1, 2, 3, 1 across, you see, I can go through the whole grid here, and it'll be the same, the same slope, 1, 2, 3, 1, and so forth. Now, equation number 2, I believe I'll show my students how to graph it by using the x and y intercept because that'll be easier for this one. But let's keep it uniform how we did also equation 1. So let's put it in the slope intercept form, which means let's put it in the form y equals to mx plus b. Okay. So for example, equation 2 is not in that form, right? So how do we put it in that form? We have to solve for y because it has to be y by itself or isolated on the left side, and we send everything else to the right side, and then we'll see what's my slope and also my y-intercept. So we start off by adding 5x to both sides, right? And then after that, we divide both sides by -2. And this is what it gives us. Y equals to -5/2x plus 5. So we know that my slope is -5/2. We know my b is equal to 5. And the y-intercept is 0, 5. So again, the b or the y-intercept is my starting point. So it's going to start up all over here on the positive y. The 5 on the y, which is right there. Then, right, since it's negative, I'm going to go down 5. 1, 2, 3, 4, 5, and 2 to the right. 1, 2. That's my point. And then, like I said earlier, we only need 2 points to graph a line. So we connect those 2 points, and that's my line. So where do they intersect? This is my solution, right? Because here's where the both lines intersect, which is going to be 2, 0. And again, the point where both lines intersect is a solution, which is 2, 0. That's how you graph. That's how you solve the system, by graphing. Graphing is okay to do, but at times when the equations are real, like with real big numbers, I don't recommend to do it by graphing. There's other ways to do it, which are by substitution and the elimination method, which I'm going to show you on the next few slides. Okay, now, so again, this is consistent independent system because we have one solution. Okay, now let me do the very same system of equations, but instead of graphing, let's do it by substitution. Okay, when you do it by substitution, you see you have to have the y or the x isolated, right? So you always try to find which variable is isolated. For example, here we know that equation 1, right? The y is by itself or isolated. And I can put here for the solution, since y is isolated on equation 1, we're going to substitute 3x minus 6 for y on equation 2. So in other words, I'm going to plug in 3x minus 6 inside the y here. Okay. You see, guys, there is some space because y is equal to 3x minus 2. So I'm going to plug it in there, right, for the y. And then I'm going to distribute the -2 times 3x and the -2 times -6. And this is my result. Now I get to combine like terms. So -5x and -6x are like terms. So -5 minus 6 will give us -11x plus 12 equals to -10. Now we have to solve for x, right? So we're going to subtract 12 from both sides. So it's going to give us -11x equals to -22. Then we divide both sides by -11, which will give us x equals to +2. Now, right, but the answer has to be a point. You have to have an x value and a y value. So now, right, so now we need to find the y value. So we're going to plug in 2 for either, 2 for x in either equations 1 or 2, whatever is easier for you. Okay? The more that you do these, the more you're going to know right away which one will be easier for you guys. Like I tell my students, it's up to you what you want to plug it into. For some students, it might be easier equation 1, and for some others, equation 2, but it's all up to you. It's not about the instructor or about other students. It's up to every student individually. Okay? So for example, I'm going to share with you guys what I will do. Okay? What I would do here, I will plug in the value for x on equation 1. Why? Because y is already isolated. So all I do is plug it in for the x here, guys, and then we simplify and we get our answer, right? So we're going to plug in 2 here for the x. So 3 times 2 is 6. 6 minus 6 will give us a 0. So you see, guys, we get the same answer as before. X is 2 and y is 0. So that's my solution. And again, it's consistent, independent system. So I'm going to do the very same equation or systems of equations by graphing, by substitution, and by elimination method. Okay, this way you know we always get the same thing, but you decide what's easier for you. If the instructor on the exams, if they state that they want you to do it a specific way, you have to follow his instructions, his or her instructions. But if they don't say how to solve it, you can do it any way you want. So that's what I'm doing here, is showing you that there's different ways to get the answer. So if there's no manner that they want you to do it, guys, to solve it, you do what's best for you. Okay. Now let's do it by the addition method. The addition method or elimination method, it means the same thing. There are some authors in different books that use the addition method. In this book, on the 1324, they call it the elimination method. Okay, now, but for the elimination method, both equations have to be in a specific way. Okay, again, it's called equation 1 and equation 2. You see, to use the elimination method, both equations must be in the form of ax plus by equals c. In some books, this is called a general form. For example, in the book that we're using right now, they just say the rule. The rule ax plus by equals c. Okay, so but this is what it means. But anyway, I mean, that's why I didn't call it a specific name, because in this book they just say the rule ax plus by equals c. So that's why I just stated here ax plus by equals c. So both equations 1 and 2 must be in this form here. If we notice, equation 2 is already in that form, right? Because we have a negative 5x minus 2y equals to negative 10. But equation 1 is not in that form. So we need to rewrite it in the proper form so we can use the elimination method. So here, guys, we're going to have to subtract 3x to both sides, right? Because we want the x and the y on the same side and the constant on the right side. So if we do that, we get negative 3x plus y equals to negative 6. So now we have them both in the same form of the form of ax plus by equals c. So now here, hey guys, here is where students at times get confused because they don't know what to get rid of. Should we get rid of the y's or the x's? So it's up to every individual how they want to perceive it. Okay, again, in my opinion, I would get rid of the y's because it'll be easier. As a matter of fact, I believe I'm going to do this one both ways. First, I'm going to get rid of the y's, and then on my next slide, I'm going to get rid of the x's, just so you know that getting rid of the x's is a little bit more work. Okay, so again, I will get rid of the y's because I just need to multiply equation 1 by 2, because 2 minus 2 will give me a 0. Okay. So again, but in math, you just cannot just multiply 2 by a single term in an equation, right? You have to multiply 2 to both sides of the equation, which means I have to multiply 2 times every term. So if I multiply 2 times negative 3, and 2 times y, and 2 times negative 6, this is my result. Okay, now, here, right, so equation 2, we just bring it down how it is. If you notice, right, when we add them, the y's will be eliminated because 2y minus 2a will give me a 0. So we add the x's, that's going to give me negative 11x. We add the constants, which negative 12 minus 10 will give us negative 22. And after that, all we do is divide by negative 11. If we do that, we get x equals 2. Now, we repeat the process, what we did in the previous slide, when you do it by substitution, right? Once you get the x or the y, then it's up to you where you want to plug in the value that you just got. For example, here we just got 2 for x. So again, I can go back to either 1 or 2, but I can go back to the original, right? And in my opinion, we can go back to number 1 here, how it was in the original state. So again, I plug in 2 for the x. So we got 6 minus 6 equals 0. So we know that the solution is going to be 2, 0. Okay. Now, and again, it's consistent because there's one solution. Now, let's do this very same one, right? Again, but instead of get rid of the y's, we're going to get rid of the x's. Okay. And again, all this repeats, right? It's the same thing as the previous slide, but here's where we're going to do something different. So check this out. So to get rid of the x's, if you notice, they're both negative, which means I need to multiply equation 1 or equation 2 by another negative. That way it'll be positive. Okay. So I need to multiply equation 1 by 5 or negative 5 and equation 2 by 3. Okay. So again, right, by negative 5, because 3 times negative 3 times negative 5 will give us a 15x. And then we multiply the second equation by 3, because 3 times negative 5x will give us a negative 15x. And this way, the x's can be eliminated. Okay. So here we have 15x minus 15x, those be eliminated. We have negative 5y minus 6y will give us negative 11y equals to 0. We divide both sides by negative 11, so we know that y equals to 0. Now we need to find the x value. So we can plug in 0 for y in either equations 1 or 2, whatever is easier for you. In my opinion, I believe it'll be easier. I mean, I can even, if I would have chosen equation 1, right, I would have plugged in a 0 there, right? Then it's more work. That's why the wise choice will be equation 2. But even if you plug it in equation 1, you still get the same result. Okay, so I'm going to plug in 0 for the y in equation 2. So this will give us negative 5x equals to negative 10. We divide both sides by negative 5, and the result is x equals to positive 2. So again, what's my solution? Is 2, 0. If you notice, we got the same solution for either way that we solved it, by graphing, by substitution, and by the elimination method. Then if you want to check your work, go a little bit further, do what we did on the first slide that I showed you, right? Let's see if 2, 0 is the solution. So you plug in 0, 2 for x, and 0 for y on both equations. And if it makes it true, it means it's a solution. But I know it's a solution, so I'm not even going to do that. But you can even go back and check, okay? Okay, now. And again, it's consistent because there's one solution. Okay, now, let's see what happens. Okay, I'm going to continue solving by systems of elimination. Because remember, I told you guys that we're going to get something that you have like the a equals to a, like the same numbers equals to each other, and there's no x or y. Here's an example. Okay, so for example, we have equations 1 and 2, and it says to solve the system by elimination. So here, guys, I get rid of the x's, right? Or it doesn't matter. I need to multiply equation 1 by negative 2. Now, if I multiply negative 2 times 3x, negative 2 times negative 2y, and negative 2 times 4, this is the result. And then equation 2, we just bring it over. And if you notice, right, we get 0 equals to 0. Remember I mentioned that? I believe that was like the graph B on the second slide. When we have 0 equals to 0, which means this is true, but we don't have no x's or y's, which means this will be infinite solutions. Okay? And it was consistent, but consistent dependent systems, because the y depends on the x, okay? Or vice versa, I mean, in this case. Now, number 7, okay? So again, equation 1 and 2. So I'm going to get rid of the x's, right? So I'm going to multiply equation 1 by negative 3. So if I distribute or if I multiply negative 3 times every term on equation 1, this is what results. Negative 6x minus 15y equals to negative 24. So equation number 2, we just bring it over or slide it over, and then we add them. So this will give us a 0 and a 0. So 0 equals to 6, to negative 6, which means this is not true, right? So this has no solution, which means that these two lines or these two equations or the lines, if you graph them, they're going to be parallel. Okay. No solution, and this is called inconsistent system. Okay. And I believe every instructor, when they assign homework, they always give you maybe 2 with one solution, and maybe they also give you I mean, some of these. So expect these on your homework, because I always get them on the homework, even on the exams at times. So please know when you have infinite solutions and no solutions. Okay, now how does this apply to real life? Okay. Because many students at times, they say, Mr. Sassi, well, how does this relate to real life? Well, here's a good example. This is number 8. Okay, here we go. It says a 200-seat theater charges $8 for adults and $5 for children. If all seats were filled and the total ticket income was $14,435, how many adults and how many children were in the audience? Okay, so here's my strategy that I tell my students. You need to find 2 equations, okay? So I always tell them that they're going to go seats with seats, or people with people, and money with money. What does that mean? Okay, this is what it means. I'm going to let X, right, be adult tickets because it's first, and I'm going to let Y equal to children's tickets because it's second, right? And so this is what it means. X amount of seats plus, X, which means adult seats plus children's seats, must equal to 200 because there's 200 seat theater. So it's going to be X plus Y equals to 200. Now we're going to do money with money. Okay. So adult tickets are $8. And adult, and the X stands for adult seats, right? So it's going to be 8X. And then we're going to get children's tickets equals to $5, right? So children's tickets or children's seats is Y, so this is going to be 5Y. And what was the total income? 1,435. So there's my equation. So it's going to be 8X plus 5Y equals to 1,435. I found my two equations. Now, this will be very, very difficult to do it by graphing. That's why I said that the graphing will be good, right? But I don't recommend graphing with word problems because most of the times the numbers are real big. Okay, also you can do it by substitution or by the elimination method. But I like to use the elimination method. Why? Because they're already set up in that form. Okay, so here we go. So here it doesn't matter what you get rid of, the x's or the y's, because they're both the same. Why? Because the x and the y are the coefficient is 1. So I believe here I'm going to get rid of the x's, I believe. Yes. So negative 8 times x and negative 8 times y and negative 8 times 200. That's my result. And then equation 2, all I do is slide it over. Well, now we add the terms. So negative 8x plus 8x, they'll be eliminated. Negative 8y plus 5y will give us a negative 3y. And negative 1600 minus 1435 will give us negative 165. Now we divide both sides by negative 3. And we get y equals to 55. So there's 55. 55 is y, right? So now we go back and plug in 55 for either equation 1 or equation 2. In my opinion, equation 1 will be easier. Why? Because the coefficients are very, very small compared to equation 2. Right? So let's go to equation 1. We know that y is 55, so I'm going to plug in 55 for the y. And we subtract 55 from both sides. So x equals to 145. So my x is 145. My y is 55, but that's not what they're asking. They're asking how many adults and children are there. Since x represents adults, so it's going to be 145 adults and 55 children in the theater. Okay, that's how this can be applied to a real life situation. Okay, now this is larger systems of linear equations. I believe this is something from 6.2. I believe this PowerPoint or this week covers 6.1 and 6.2. Okay, now these are larger systems of equations, which means you can have 3 variables. You can have x, y, and z. Okay, now I'm going to call it equation 1, equation 2, equation 3. At times, students ask me, Mr. Isasi, so how can we start? Or how do we do this? Or what's the plan? At times, guys, in math, there's really no steps. Or at times there's steps, right? But minimal steps. It's rather good to know the concept, because knowing the concept, you can use different ways to get the answer. But in this course, the 1324 course, most students that are taking this course, they're not going to be math majors, no engineers. Perhaps they're going for something that doesn't require no math, or if it requires math, they're probably going for accounting or business. And if you're going for accounting or business, you have to take another math class. Okay, so that's why I come up with a plan. Okay, and if you follow these steps of this plan, you can never go wrong. When you try to do things that's not according to the plans, then you really have to know what you're doing. Okay, so the way I do this solving systems of equations, larger systems, I assume that the students they don't know nothing, and whatever they know will be a benefit to them. This way, none of my students get left behind, because that's the objective of my teaching style, is that I don't want nobody to be left behind or feel that they're lost. So that's why I try to make it as simple as possible. Okay, so to start off, it's always wise to have one of the isolated variables, especially the x, on equation one. Okay, and there's a reason for that, which I'm going to show you or explain to you later. Okay, so you can always start that at the beginning. Rearrange if possible, coefficient of 1 on the x being equation 1. So I can switch equation 1 and equation 2. Okay, I just switched those two. Okay, now, so here we go. Okay, so this is the plan. What's the plan, right? This is the plan. I'm going to get equation 1 and equation 2 and get rid of the x's. And I'm going to get equation 1 and equation 3 and get rid of the x's, right? Eliminate the x variables for these two. So I'm going to get equation 1 and 2, and 1 and 3, get rid of the x's. Then you're going to have, I believe I call it a new equation 2 and a new equation 3. These two equations, the new equation 2 and the new equation 3, they don't have x's, right? Because they were eliminated. So now I'm going to get the new equation 2 and the new equation 3 and get rid of the y's. Then after I do that, I'm going to have a new equation, which is z equals to a number, or z equals to any number, and let z be a real number. After all these steps, the equation should look something like this. Okay, which I'm going to explain to you how to do that step by step. And then what we do here, guys, is back substitute to get receipt, because we already know what negative 1 is. Then we plug negative 1 on equation 2, right? And plug it in there for z, and then we have y, we can solve for y. Then we have negative 1 for z and a value for y, we plug them in on equation 1, and we solve for x. So those are the plans. If you follow these plans, guys, you can never go wrong. Okay, so let's put it to the test. Okay, here we go. So what were the rules, right? We get equation 1 and equation 2 and get rid of the x's. That means that I'm always going to be using equation 1, right, to multiply by something to match the x value on equation 2, right? So this way, it'll be easier to always have x with a coefficient of 1 on equation number 1. So then I'm going to multiply equation 1 by negative 2. Again, why negative 2? Because negative 2 times x will give me a negative 2x, and then when I add it to the second equation, they'll be eliminated. Okay, so that's a plan. But I have to multiply negative 2 times every term on the equation. Okay, so if I multiply negative 2 times x, negative 2 times negative 3y, negative 2 times 2z, and negative 2 times 0, this is the result. Then equation number 2, all I do is slide it over, right? If you notice, we have a new equation. So this is my new equation 2. You see, no more x's. Now we repeat the process for eliminating, having a new equation number 3, right? So again, the first step is you use 1 and 2, get rid of the x's, 1 and 3, get rid of the x's. So let's do the same procedure as we did on equations 1 and 2. But if you notice, right, this is a 3 on equation number 3. So I'm going to multiply equation 1 by negative 3. So after I multiply negative 3 times every term, we get negative 3x plus 9y minus 6z equals to 0. The equation number 3, we just bring it over or slide it over, and then we just add them. You see, the x's are eliminated. So this is my new equation number 3, which is, right? Now, which is 10y minus 7z equals to 7. Now, we're going to get the new equation 2, the new equation 3, and we're going to get rid of the y's. Okay, now, here, I know that the least common multiple for these two equations is 20. But at times, students have a hard time trying to, they say, well, why is it 20? Because the least common multiple that the 4 and the 10 can go into is 20. Because 4 goes into 20 five times, and 10 goes into 20 2 times. But I don't want you guys to be stressing, right, to find the least common multiple. So what I do, we know we have a 4 here, we have a 10 here, right, for the y's. They're both positive. So equation 1 must be multiplied by negative 10. And equation 2 by negative 10, and equation 3 by 4. Right? If you notice, the negative 10, right, goes over here on top, and the 4 on the bottom. This way, both will give me a negative 40 and a positive 40. Okay? And once you know if you can be simplified easier, right? Like for example, I know 20 will be the least common multiple, but then the more that you do the practice, the more that you can understand what will be easier. But here I'm assuming that you guys don't know nothing, guys, right? This way, whatever you know is a bonus for each individual student. So now I need to distribute, right, or multiply negative 10 times every term on equation number 2. And that's what results. And the same procedure, I'm going to multiply 4 times every term on equation 3. And that's what we get. If you notice, the y's will be eliminated. So I have 2z equals to negative 2. Now I solve for z. We divide both sides by 2. So I know that z equals to negative 1. You see now, guys, I have the equation, right? I have equation 1 will be the x minus 3y plus 2z equals 0. And equation 2 can be either one of these two. But I chose the one that looks easier to solve, which is a 4y minus 3z equals to 3. And we have z equals to negative 1. So we know what the z is already, right? Negative 1. So now I'm going to back substitute. So I'm going to go to equation 2 and plug in negative 1 for z. So this will give us 4y plus 3 equals 3. We subtract 3 from both sides. So we get 4y equals to 0. We divide by 4. So y equals to 0. Right? So I already found the values for y and the values for z. Right? So now I'm going to plug in the 0 for y and the negative 1 for z. And after we do that, right, we simplify it on the left side. So we get x minus 2 equals 0. So we get x equals to 2. So we got the value for x. So we know the answer will be 2, 0, negative 1 is my solution. At times, students ask me, Mr. Isasi, can we plug in the x, the y and the z on equations 2 or 3? Yeah, you can. But always equation 1 will be easier, right? Because at the beginning, we kind of switch equations that the one with a coefficient of 1 will be easier to work with. And it was, right, throughout the process, it was very simple to work with. But if you don't rearrange it at the beginning, it's a little bit more work. Okay, that's why everything that I do is always for the benefit of the students, that it will be easier for them. Okay, so, and again, you can plug in the y value, which is 0, and the z value, which is negative 1, on either equations 1, 2, or 3. You will always get the same answer. Okay, but anyway, my solution is 2, 0, negative 1. Okay, now this is called the Gauss-Jordan elimination method. Okay, this is another way to solve systems of equations. So this method, guys, is a little bit challenging. Okay, I don't want to lie to you, or I don't want to sugarcoat it. This is a little bit challenging. At times, when I explain this method in my class, it takes the whole 50 minutes if it's a Monday, Wednesday, and Friday class. It takes a whole hour to explain it. And at times, students still don't understand what to do. So that's why, guys, I tell my students in class, hey, guys, don't even go to the bathroom, don't even blink, because you have to be paying attention the way it works. So I brought the way I modified this method, I brought it into a PowerPoint, which will be easier for you guys to follow. Okay, and I believe this is very, very, it's called, easy to follow for students. I even shared this system, or this way of solving the equations with some of the tutors there at TM and also at Valle Verde, and they told me that I make it real simple to follow. So hopefully that'll be the case for you guys too. Okay. So anyway, we're going to go from linear systems of equations to augmented matrix, which I'm going to tell you what it means, and then to the matrix of RREF means reduced row echelon form. And I can show you also how to put it in the calculator, guys, but the instructors, they always want to show, they always want to see the work. Okay. This is an example of systems of linear systems of equations, and the augmenting matrix, right? We're going to put into a matrix. We only get the coefficients, so this will be 1, negative 3, 2, 0, right? We only get the coefficients. This is the x column, the y column, the z column, and the constant column. So the next equation 2, is going to be 2, negative 2, 1, and 3. And also equation 3 will be 3, 1, negative 1, and 7. So after we do all the work, this is going to be the answer. This is what it means by having it in reduced row echelon form. If you notice, all the ones diagonally, I mean all the diagonally here on the matrix, they're all ones, which means this is x, this is y, this is z, right? So then these will be my answers. For example, this is the same thing as 1x plus 0y plus 0z equals to 2, which means x equals to 2. The second equation means 0x plus 1y plus 0z equals to 0. So in other words, y equals to 0. And lastly, we have 0x plus 0y plus 1z equals to negative 1, which simplifies to z equals to negative 1. Okay, now, how is it possible? Well, it's very simple, right, to plug into the calculator, but I'm not going to use a calculator. We're going to do it by hand. Okay, so I'm going to show you, I call it the three-step plan. When the book explains it, and I believe also the instructors, because when I was taking this course, the instructors used like about 8 to 9 matrices to get the answer. The way I'm going to show you guys is only three at the most, four steps. But usually there's only 3 steps. Okay, so I'm going to show you the steps. Okay, I'm going to use just letters. Okay, just letters to explain the concept here. So I put here, let all letters be real numbers, right? These can be all real numbers. So again, so the answer will be something like this. Okay, after I'm done, you see that's the answer for x, the answer for y, the answer for z. Okay, now here we go. This is row 1, row 2, and row 3. So my first step, if you notice, right, it's also color-coded, so that way it can match here. The first step, I have to make the place of the e and the I equal to 0, right? That's why this row 2 is going to change, and row 3 is going to change, right? Because the e and the I must be zeros to match the first step. Okay, now after I do the first step, right, it's in blue, right, I get the zeros there. Now for step number 2, if you notice, the first column, the first row, the second place here, it has to be a 0, and also the second column, the third row must be a 0, so the B and the Q must be zeros. So I have to change, or I have to work with row 1 to make that a 0, the B. I have to work with row 3 to make the Q a 0. So after I execute that plan, you see we get 0 for the place of the B and the Q. You see, so almost done, right? So then the third step, you see, if you notice here, on top here, you see the plan is for equation 1 on the third column to be a 0, on equation 2, the third column also to be a 0, so the u and the n must be zeros. So then that means that I have to work with equation 1 and equation 2. So after I do the operations, right, so this is what I should get. And I say here, simplify if possible as you do a step, because this way you eliminate an extra step, which is step 4. You see, that's your answer. Okay, so now let's put it to the test. I don't know, one more way that I want to explain it. At times, students, they get real confused when they have a lot of letters. For example, when I was in school, I used to be all confused when the instructors used like the concept, when you explain the concept, it's all about letters because you're trying to prove something, right? So, but here, for the sake for students to feel a little bit better, I do use number signs, right? Because all these are going to be numbers, right? And we do it the same way, right? The steps. So I'm going to go a little bit quicker, right? But it's the same process as the previous slide, but instead of letters for real numbers, I just put number signs. You see? So again, after step 1, these two must be 0, so they are, right? Step 2, the one here on top, on the first row and the third row, the second column, they must be 0, which they are. And then lastly, right, the first row, third column, and the second row, third column, those must be zeros. And then that's when you know that you're done. Okay. And like I said, I don't want none of my students to fall behind, because I know and I understand that some students get all confused when the instructor begins using a lot of letters, because some of us have enough letters with X and Y. Now, by having A, B, C, D, and all that I put in the previous slide, students might get confused, especially if they have a hard time with with mathematics. Okay, so I'm trying for all the students to feel comfortable. Okay, now, so let's put this is number 10. Let's put the 3-step a plan in action. Okay, here we go. Right. So this is row 1, row 2, row 3. This is our augmented matrix. So if you happen to put in the calculator, right, this is what you will get. So I always tell my students, I show them how to use a calculator, and then I show them, but you have to show them the work. This is how to check your work. Okay. So now, so if you notice here, we have right. This is row 1, and then row 2 will be the 2, -1, 1, 3, and this is row 3. So step 1. Step 1, we're gonna keep row 1. Right, we keep row 1 how it is because only row 2 and row 3 must change. So the 2 must be a 0, right, to match row 1. I mean to match step 1, and also the 3 must be a 0. So I have to work with these two rows here using equation 1. So you notice, right, this is a 1 here. So I'm going to multiply -2 times row 1 and add it to row 2. Why? Because -2 times 1 will give me a -2, and if when I add it to 2, they'll be eliminated. In a similar manner, I'm going to multiply -3 times row 1 and add it to row 3. And here's my work. You see, it's all color-coded. So -1 row 1, I'm going to multiply -2 times row 1, right? No, row 1 was 1, -3, and 2, and 0. So I'm going to multiply -2 times each of those terms. This is this is my result. Then I'm going to add it to row 2. So row 2 just slides over. So we got 2, -2, 1, and 3. Then when we add them, right, this is my result. We got 0, 4, -3, and 3. So this is my new row 2. Now, I'm going to repeat the process, right, to eliminate the 3 in row 3. So this is my -3 row 1, right? This is what I'm executing, right? Here where I put the arrow. So -3 row 1 is -3 times row 1. I'm going to multiply -3 times 1 times -3 times 2 and times 0, which will give us -3, 9, -6, and 0. And then I'm going to add it to row 3. So row 3 just slides over. So row 3 was 3, 1, -1, and 7. So that's what I bring over. Then I add them. So this is my result. 0, 10, -7, and 7. So that's my new row 3. Okay, now I'm going to go to the next slide, okay? Because in the next slide, I'm going to explain every step in different slides. And then at the end, we're going to do all one in one slide, okay? So I'm going to go to the next slide. And we have to remember the plan, right? This was what I got after I did it, executed step 1. So I just brought that over, but I put the reduced row echelon form here on top just so we remember the plan, right? So the plan now is step 2, which is color-coded in green. Okay, so step 2, we're going to keep row 2. Okay, again, step 1, we keep row 1 how it is. The step 2, we're going to keep row 2 how it is. And step 3, we're going to keep row 3 how it is, okay? But check this out. So the -3 here must be a 0 and also the 10, right? Because that's according to the plan there. But I'm going to be using, right, row 2 to eliminate those. So here, right, so I'm going to multiply, we already have a negative and a positive, so I'm going to multiply row 2 times 3 and row 1 times 4. So, and then in a similar fashion, I'm going to multiply -10 times row 2 or times 4 right there, and then the 4 times 10. That way they'll be eliminated because they'll give a 40 and -40. So now here's my work. This is 3 row 2, which I'm going to multiply 3 times row 2, which will give us 0, 12. 3 times -3 is -9, and 3 times 3 is 9, right? And then we also have to multiply row 1 by 4. So 4 times 1 is 4, 4 times -3 is -12, 4 times 2 is 8, and 4 times 0 will give us a 0. Now we add them. We have 4, 0, -1, and 9. So this is my new row 1. Now, right, the second part, we're gonna do the -10 row 2 plus 4 row 3. There's my -10 row 2. I multiply -10 times the whole row 2, and that's my result. Then I'm going to multiply 4 times row 3, right? And there's my result. So we execute the the operation here, which we add them, we get 0, 0, 2, negative 2. Remember that I said that we simplify every step if we can? So here we simplify. Why? Because we can divide every term by 2. And if we do that, that's what it will give us. So this is my new row 3. If you notice, it's already taking shape as the last row is already in the form that we wanted to. So we know that z will be negative 1. Okay, now why didn't I simplify here on the previous one, right? Because we have 4, 0, negative 1, and 9. If we want to divide everything by 4, we're going to get fractions. And most students, they have a little bit of a hard time with fractions. So that's why I try to eliminate the fractions until the very end, if there's any. Okay. So now let's continue with step 3. So step 3, right, I'm going to keep row 3. So then if we notice, the negative 1 must be a 0, and the negative 3 must be a 0. So I'm going to be changing row 1 and row 2. And we're going to be using row 3. So if we notice, right, row 3 here on the Z column, we already have 1 and negative 1. So all we do is add these two rows. So row 3 plus row 1. And to eliminate the negative 3, right, so we're going to multiply 3 times row 3 and add it to row 2. And here's my work. Right, so we have 4008, and we simplify, right, because we want this to be a 1. So if we divide everything by 4, it's going to give us 100. So that's my new row 1. Then I repeat the process, right? So 3 row 3 is going to give us 003, negative 3, plus row 2. Row 2 is 04, negative 33. So after we add them, we got 0400. We divide everything by 4. So this is my new row 2, 0100. We notice? So x equals to 2, y equals to 0, and 1, and I mean z equals to negative 1. I'm sorry about that. So these are my solutions. Okay. Now, let's do one. Okay, I put it together, but I don't believe we have enough time for me to do it together. Okay, so I'm going to do it here. I'm going to do the same process here, guys. Okay, but this is how I tell my students to work it out. All right, so here we go. So we start step 1, right? So the 2 on the second row must be a 0, and also the negative 1. So I'm going to keep row 1. So I'm going to change row 2 and row 3. So I'm going to multiply negative 2 times row 1 and add it to row 2. I'm just going to add row 1 plus row 3, right? Because 1 minus 1 will give me a 0. So I'm going to add row 1 plus row 3. And here's my work. Okay. So negative 2 row 1. So it's going to give us negative 2, negative 4, 2, and negative 12. And then add it to row 2. It gives us 0, negative 5, 5, and negative 5. And this can be simplified, right? Because they all have a multiples of 5. So we can divide everything by negative 5. So we get 0, 1, negative 1, 2. So this becomes my new row 2. Now, let's do the row 1 plus row 3. Right, there's my row 1, there's my row 3. And if we notice, we get 0, 1, 0, 1. So this is my new row 3. Now we're going to do step 2. So step 2, right, we're going to keep row 2. And the 2 on the first row, second column must be a 0, right? And also the second column on row 3 must be a 0. So we're going to change row 1 and row 3 by using row 2. So here we're going to multiply negative 2, right, times row 2 and add it to row 1. And here on the bottom, right, we're going to multiply negative 1 times row 2 and add it to row 3. And here's my work. Okay, so negative 2 times row 2 is going to give us 0, negative 2, 2, and negative 4. And we're going to add it to row 1. This gives us 1, 2, negative 1, 6. So we add them. We get 1, 0, 1, 2. So this is my new row 1. And now we do the negative 1 row 2 plus row 3. That's my negative 1 row 2. And this is my row 3. We just bring it over. So after we add them, we get 0, 0, 1, negative 1. So that's my new row 3. Now, right, we're up to the third step. So for the third step, we're going to keep row 3. So the 1 here in green has to be a 0 on the first row, third column, and also the second row, third column. These two must be zeros. So I'm going to change row 1, and I'm going to change row 2. So I'm going to multiply negative 1 times row 3 and add it to row 1. Then, since this is already a negative and a positive, I'm just going to add row 3 plus row 2. And here's my work. So negative 1 row 3 is going to give us 0, 0, negative 1, 1, and add it to row 1. Gives us 1, 0, 1, 2. So then after we do the operation, it's going to give us 1, 0, 0, 3. So that's my new row 1. Now we're going to do row 3 plus row 2. There's my row 3, which is 0, 0, 1, negative 1. We're going to add it to row 2, which is 0, 1, negative 1, 2. After we do the operation, this is what we get, 0, 1, 0, 1. So that's my new row 2. So x equals to 3, y equals to 1, and z equals to negative 1. So that's my solution. There we go. Okay, now, how does this apply to real life? Well, here we go. I believe this is the last one, okay? So let's see here. It says here, tickets to a band concert cost $5 for adults, $3 for teenagers, and $2 for preteens. There were 570 people at the concert, and the total ticket receipts were 1,150. Now it says here, 3/4 as many teenagers as preteens attended. How many adults, teenagers, and preteens attended the concert? Okay, so let's see. What is my solution? So I need to find 3 equations, okay? And let's do it like the one that we did earlier, right? At least for the first 2. We're going to have people with people, right? People with people, and money with money to get the first 2. So we're going to let X be adults, right, in order, Y be teenagers, and Z be preteens. And what was the total number of people in the concert? 570. So this will be X plus Y plus Z equals to 570. Now, let's do money with money, right? So we know, let's see here, so $5 for the adult tickets, so it's going to be 5X, right? 5X. And then for the teenagers, that was represented by Y, so it's going to give us 3Y. And finally, $2 for preteens, and Z represents preteens, so it's going to be 2Z. And what was the total income, or what was the total amount? 1,150. So we got my second equation, which will be 5x plus 3y plus 2z equals to 1950. Okay, now, we have equations 1 and 2, but we're missing the third one. So here's where the third one comes in. Okay, I know that this seems a little bit complicated to actually set it up, but it says 3/4 as many teenagers as preteens attended. So this is what it should be. Okay, but it's kind of hard, right, to know how in the world can 3/4 as many teenagers as preteens attended be this equation here. Okay, here's why I tell my students to do it. If it is difficult, write it how it sounds and then flip it. Maybe the word flip it maybe is not the right word to use, but in this PowerPoint that's what I use. Okay, let me show you what I mean. So 3/4 teenagers, right? Teenagers is Y, right? Equals to preteens is Z. And then this is what I call you flip it. You're going to put the 3/4 where the Z is. And it works every time. Okay, because I've tried it before. It works every time. Write it how it sounds, and then put the 3/4 on the other, in front of the other variable. Okay, so this is my new equation 3, but they don't want no fractions, right? So we're going to multiply 4 times both sides. So we get 4y equals to 3z. Then we subtract 3z to both sides. So it's already set up as equation number 3. So this is equation 3. Okay. Now, you try it, right? But I went ahead and try it. But if you do it with matrix, it's a little bit more complicated. So I believe on the next slide, I did it by the method where you use 1 and 2. to get rid of the x's, and use 1 and 3 to get rid of also the x's, right? That's how I'm going to do it, but these are my answers. You can try it by using the Gauss-Jordan method, but I'm going to do it by using the three-step plan that I had, right? I'm going to use 1 and 2, get rid of the x's. So I'm going to multiply equation 1 by -5. So after I multiply -5 times every term, this is my result. -5x minus 5y minus 5z equals to -2,850. Then we add it to equation 2. This is my result. -2y minus 3z equals to -900. So that's my new equation 2. If you notice on equation 3, right, we don't need to do that step because there's no x there. So we can skip that step, right, because there's no x term. So equation 3, will be the equation that I'm going to use. So my new equation 2 is going to be -2y minus 3z equals to -900. And this is my equation 3, 4y minus 3z equals to 0. And here, guys, I'm going to get rid of the y's, right? So I'm going to multiply 2 times every term on the new equation 2. This is my result. And equation 3, we'll just slide it over. After I do the operation, the y's will cancel, so I'm left with -9z equals to -1800. We divide both sides by -9, and this is my result. Z equals to 200. Now I have my three equations, right? I have my first equation. My second equation, I can use either this one here, but I like to use the new equation 2, which is -2y minus 3z equals to -900. And we have z equals to 200, so now we're going to back substitute. So I'm going to go to equation number 2, right? And I'm going to plug in 200 for z. This gives us -2y minus 600 equals to -900. We're going to add 600 to both sides. Then we divide both sides by -2. So we have y equals to 150. Now we have the z and the y. Now let's plug it in for equation number 1. We're going to plug in 150 for y and 200 for z. After we add those, then we subtract 350 from both sides. And this is my result. So x equals to 220. So x equals to 220, y equals to 150, and z equals to 200. But I recommend, if you're going to be taking the 1325 class, to please try it with the Gauss-Jordan method, because I believe the first section and some teachers cover chapter 7, and you have to know about the Gauss-Jordan method. And other teachers, they skip it because it's optional. Okay, but I recommend for you guys to practice the Gauss-Jordan method on this password problem, right? So this is already your setup, but use it by using the Gauss-Jordan method for practice. Okay, guys, well, thank you very much. And I thank you for staying a little bit later, like 5 minutes later. But that's it for my presentation. And hopefully it will be useful for you guys. Thank you very much.
Thank you, Mr. Azasi. At this time, is there any questions for Mr. Azasi? If not, I'd like to invite you all to join us next week. So next week for Happy Math Hour for Math 1314, we'll be going over properties of logarithms, exponential and logarithmic equations. And then for Math 1324, we'll be going into matrices once again with basic matrix operations and inverses. So feel free to join us. And as always, Mr. Azasi always offers a copy of his PowerPoints. So if you would like to get a copy, you can go ahead and send him an email. I'd like to take a moment and say thank you to Mr. Azasi for presenting today. Thank you all for joining us this Friday, and we hope you have a wonderful weekend.